Hey, welcome. We're going to do Module 3, Task 4, working with radicals, which are like the square root symbols. So when you see radical, think of that symbol. Okay. They show you a couple properties which are definitely useful here. You can see that, get this guy over here. You can see that the nth root of a to the n is equal to a. So that works. So anytime you see the square root of, say, 4 squared, you get 4, or the cube root of 2 cubed, you get 2. Some other ways you can break it up, which are useful, is the nth root of ab is equal to the nth root of a times the nth root of b, or also the quotient, nth of a divided by nth of b. So we may use those as we work through these. There's some other ones. These are actually the exponent rules that you've done before, so you might want to take a look at those, make sure you understand those. And then they ask you to give an example to show why the a to the 1 nth is equal to the nth root of a, and why is a to the m-nth equal to the nth root of a quantity to the m power. I used some numbers here. So a to the 1/3, 8 to the 1/3 is 2. We're trying to show is equal to the cube root of a. And then we're trying to say the reason that, so 8 to the 1/3 is 2 because 2 times 2 times 2, or 2 cubed, is 8. So we know that when we multiply this 3 times, if we did it with exponents, we would have, instead of 2 times 2 times 2, we have 8 to the 3rd times 8 to the 3rd times 8 to the 3rd. Adding the exponents gives us 8. So that's an example of why that's true. And then they ask you to do some problems. So let's say the square root of 27 using radicals. So the square root of 27 we can rewrite as the square root of 9 times 3. And we can break these out and change the order. Square root of 3 times the square root of 9. Square root of 9 is going to be 3. Square root of 3 we're going to leave as it is because we want exact. Okay. If you punch that in your calculator, it only gives you an estimate. So a lot of times you want the exact value. Same thing with exponents. We could say, what is 27 to the 1/2? And we can rewrite that as 3 times 9 to the 1/2, or we could rewrite that as 3 to the 1/2 times 9 to the 1/2, and therefore we get 3 times 3 to the 1/2, which is also the same thing as 3 times the root of 3, and it is exact. Let's try one a little more complicated. If we want to use radicals for Tia's method, we can rewrite this as the root of 16 times the root of x times, oh, this is the cube root, so I got to be careful here, cube root of x times the cube root of y to the 5th. And that is divided by the cube root of x to the 7th. Yeah, this is a good one, huh? Times the cube root of y squared. Now some of these we can simplify, some of these we can't. So the first one I'm going to rewrite as the cube root of 8 times 2. And then I'm going to do the cube root of x. There's nothing we can do about that. And then I'm going to do the cube root of y cubed times y squared. And this is going to help us to simplify. On this side, I'm going to say the cube root of x squared cubed, that's x to the 6th, times the cube root of x times the cube root of y squared. So we made some changes to a few of these. We changed 16 to 8 times 2. We also changed y to the 5th to y cubed times y squared. We changed x to the 7th to this. And and we left the other one as it is. So then we see there's some cubes here. 2 cubed is 8. So let me do that down below. So we're going to go down to here for now. Cube root of 8 is 2 times the cube root of 2 times the cube root of x. And this is going to be times y, because the cube root of y cubed, times the cube root of y squared. And then on the other one, the cube root of x squared cubed is x squared, times the cube root of x, times the cube root of y squared. And then what we can do, hopefully, is we can factor out. These cancel out. When we divide them, we get 1. These cancel out. Okay, so anything else? Doesn't look like it. So now the final piece here would be, let's keep that where it is. The final piece would be 2 times the cube root of 2 times y cubed over x squared. Okay, so that's a little bit better. And then you can even rewrite that as 2y cubed over x squared times the cube root of 2. So it's a little bit more simplified. You could do the same thing with the exponents. Okay, I'm going to stop there, and then that ends part 1.